If you write this in a reverse order, you will get cos function. See, 1 root 3 by 2, 1 by root 2, 1 by 2, 0. So, however sine is written, you just write it in a reverse order to get a cos function. So, whatever may be the value of an angle in the second quadrant, the value of sine will be same. So, I can write this as sine 60 itself. So, let me consider the LHS. So, 1 minus cot pi by 3, which is cot 60. Cot 60 is 1 by root 3 whole square. Everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Today in this session, we are going to study about the standard angles and allied angles in your trigonometric functions. So, let us see the weightage of the chapter, standard angles and allied angles. You will be getting only one questions for 4 marks. So, here you will be learning the standard angles, standard values of certain angles, and the problems based on that will be given. So, let us see some of the trigonometric ratios of the standard angles. The standard angles are 0, 30 degree, 45 degree, 60 degree and 90 degree. And in radians, 0 is nothing but 0 radians, 30 degree is pi by 6, 45 is pi by 4, 60 is pi by 3, 90 is pi by 2. Now, let us consider all sine, cos, tan, cot, secant and cosecant. So here the values of the standard angles are given. So you need to learn these standard values. So sine of 0 is 0. So this is basically by studying the trigonometric ratios with the help of their sides and proportional. So sine 30 degree is given by 1 by 2. Sine 45 degree is 1 by root 2, sine 60 degree is root 3 by 2, sine 90 degree is 1. Now to remember the cos value, whatever you have written from 0 to 1 in 0 to 90 degree in sine theta, you will just reverse the values. That itself is the cos function. So cos 0 is 1, cos 30 is root 3 by 2, cos 45 is 1 by root 2 and cos 60 is 1 by 2. 90 degree is 0. So, next we have tan function. Tan function, we know that it is the ratio of sine with cos. So, sine by cos gives you tan. So, we can clearly say 0 by 1 is nothing but 0. So, tan 0 is 0. Next here, 1 by 2 root 3 by 2 becomes 1 by root 3. 1 by root 2, 1 by root 2 cancels 1. Root 3 by 2, 1 by 2 is root 3. 1 by 0 is infinity, so we call it as not defined. So, when denominator is 0, we consider it as not defined or infinite. So, next is cot. We know that cot is reciprocal of tan according to the reciprocal relation. So, whatever you have in tan, just take the reciprocal of the values. So, this is 0 by 1 which becomes 1 by 0 which is not defined, or the values which you have written from left to right, if you reverse it, then the values will be from right to left for cot function. So, it is root 3, 1, 1 by root 3, 0. Next we have secant. Secant is reciprocal of cos. So, whatever the value is there for cos, you just reverse it to the secant. So, it is 1, 2 by root 3, root 2, 2 and 0. And similarly, cosecant is reciprocal of sine. So, the value of sine is taken in the form of a reciprocal. So, again it is 1 by 0, so which is not defined. Then we have 2, then we have root 2, then it is 2 by root 3 and the last one is 1. So, these are the standard values of the standard angles of all 6 trigonometric ratios. So, you need to study this. You need to study all the values of these standard angles to evaluate the problems. So, once again, I'll help you to remember this in an easy format. So, you will be taken all the standard angles from 0 to 90. Learn the values of sine. So, sine is 0, 1 by 2, 1 by root 2, root 3 by 2, 1. If you write this in a reverse order, you will get cos function. See, 1 root 3 by 2, 1 by root 2, 1 by 2, 0. So, however sine is written, you just write it in a reverse order to get a cos function. Now, to need the value of tan, you just divide the values of sine and cos. You will will get tan. Once you get tan, and if you write the reverse values of then, you will get the cot. Next, sine is reciprocal of cosecant. So for cosecant, just reverse the values in sine, then you will get cosecant. Again for secant, just reverse the value of cos, then you will get secant. So this is the easiest way to remember all the standard angle and their values with respect to 6 trigonometric function. So now we will take problems depending upon the question given here. If A is equal to 60 degree, verify the following. A, sin 2A is equal to 2 sin A cos A. B, cos 2A is equal to 1 minus tan square A divided by 1 plus tan square A. So let me take the first problem. We need to show that sin 2A is equal to 2 sin A cos A. So let us consider the left hand side. So sin 2 into A is 60 degree. So here 60 degree is nothing but 120 degree. So next, after studying the standard value, we need to learn about the sign of all trigonometric functions in the quadrant. So we know that a plane can be divided into 4 quadrants with the help of coordinate axis. So this is the first quadrant, second quadrant, third quadrant, and this is fourth quadrant. So we have 6 trigonometric function here: sine, cos, tan. Similarly, we have cot, secant, and cosecant. So in the first quadrant, all trigonometric ratios are positive. So we divide this entire coordinate from 0, 90 degree, 180 degree, 270 degree. So here you can clearly see the first quadrant is from 0 to 90, second quadrant is from 90 to 180, third quadrant is from 180 to 270, and fourth quadrant in 270 to 0 degree. So here the angles are divided here within the 4 quadrants now. So next, any value sine to 0 to 90 degree. So sine 0 to 90 degree, from the standard values also we have seen. So whatever the values we got, for all the 6 trigonometric ratios, it was positive. So in the first quadrant, all functions are positive. Whereas in the second quadrant, sine and cosecant. So sine and cosecant or the reciprocal relation functions are positive. The rest of them all are negative. So in the first quadrant, second, third and fourth. So here first, second, third and fourth. So we can clearly see here all of them are positive. In the first quadrant, all of them are positive. So in the second quadrant, sine and cosecant are positive, which means all the remaining functions are negative. Next, in the third quadrant, tan and cot are positive. So tan is positive in the third quadrant, cot is positive in the third quadrant, and the remaining functions all have negative values. So next, in the fourth quadrant, cos and secant are positive. So cos and secant are positive, whereas the other remaining trigonometric ratios are negative. So the value of an angle, for example, I told you sine 90 is 1. But when you consider sine 90 plus theta, which comes in the second quadrant, again the value, whatever the value, will get positive. But when sine comes between 180 to 270, whatever may be the angle, the value will be always in the form of negative. So therefore, by looking these observation, we have a rule called ASTC. So A is all sine, tan and cos. It represents. So we remember a shortcut that all students take coffee. All students take coffee. It's a rule, but it is easy to remember. So you can clearly say A represents all are positive in the first quadrant. Here S represents sine, and along with sine, cosecant are positive. Next, T represents tan. Along with the tan, its reciprocal relation, cot is positive. The last one represents cos. So cos and secant will be positive in the fourth quadrant. So very easy to remember. We should follow ASTC rule to remember the signs of all trigonometric ratios. So now we have learned only the standard values from 0 to 90 degree. What in case if you have the values more than 90 degree? For example, 120 degree. See, 120 degree can be written as a sum of two standard angles. So, or we can write it in the form of 90 plus 30, which are called as compound angle, which you will be learned later. But always remember, any other angle, if it is greater than 90, it will be always written in the form of 180 plus or minus theta, depending upon the ASTC rule. If it is 180 minus theta, so this is your 0, 90, 180, 270. So either the angle will be written in the form of 180 plus or minus theta, or we can also write in the form of 180 plus or minus theta, or we can write in the form of 270 plus or minus theta, or 360 plus or minus theta. But remember, where the angle lies and which quadrant the function will lie depending upon the sign values changes. For example, let me take the value of sine 120 degree. So, sine 120 degree can be written as sine 180 degree minus 60 degree. So, when I say 100 and minus 60, it always comes in the second quadrant. And in the second quadrant, the sign value is positive. Remember ASTC rule? So, ASTC. So, whatever may be the value of an angle in the second quadrant, the value of sine will be same. So, I can write this as sine 60 itself. So, whenever you have written any theta in the form of 180 plus or minus theta or 90 or 270, 360, the value, this theta will be same here because the trigonometric values repeats after certain interval. So, therefore, 180 plus or minus theta if you have, we can write it as theta itself. But depending upon the sign, then sine 60 can be written as root 3 by 2 itself. Now, suppose we have taken it as cos 120 degree. Again, cos 120 degree can also be written as cos 180 minus 60, which can be written as cos 60. But remember, 180 minus 60 means again it comes in the second quadrant. But in the second quadrant, cos is negative. So, we will convert this in the form of minus cos 60 degree. So, therefore, this becomes minus 1 by 2. So, learning the standard angles, you need to learn the standard angle, standard values of all 6 trigonometric functions. So, what is the value of cos 60? It is 1 by 2. And since it lies in the second quadrant, it is minus 1 by 2. And so, any angles which is written in the form of 90 plus or minus theta, 180 plus or minus theta, 270 plus or minus theta, or 360 plus or minus theta here, the value of the function will remain same. For example, when we are taking the values of the function in the form of sine 120, cos 120, tan 120, cot 135 degree, then the function will remain same here, but only the sign changes depending upon where the angle lie, whether it is in the first, second, third or fourth quadrant. But whenever the angles are written in the form of 90 or 270 plus or minus theta, again here function changes to co-function along with the ASTC rule depending upon the sign, which we will study in the allied angle. But now for your reference, just remember any angle can be written as a sum of any of these standard angles. Now let us take few problems. If A is equal to 60 degree, verify the following. The first question, sin 2A is equal to 2 sin A cos A. Cos 2A is equal to 1 minus tan square A, 1 plus tan square A. First, let us verify the first question. We will take sin 2A. Sin 2A is nothing but sin 2 into 60 degree, which can be written as sin 120 degree. And sin 120 degree can be written as sin 180 degree minus 60 degree, which is equal to sin 60 degree. But when I say 180 minus 60 degree, it comes in the second quadrant. So, second quadrant sign is positive. So, it remains the same. The value is root 3 by 2. Now, let us consider 2 sin A cos A. 2 sin A means 2 sin 60 degree cos 60 degree, which is equal to 2 into Sin 60 is root 3 by 2. Cos 60 is 1 by 2. So 2 cancels. We have root 3 by 2. So therefore LHS is equal to RHS. Next we will take up the problem. Cos 2a is equal to 1 minus tan square a plus 1 plus tan square a. So cos 2a is nothing but cos 2 into 60, which is cos 120. Cos 120 is cos 180 minus 60 degree. 180 minus 60 is 120, but when I say 180 minus 60, it comes in the second quadrant. In the second quadrant, cos is negative. Then this is cos 60 degree itself. So the value is equal to minus 1 by 2. Now let's take 1 minus tan square a, which is nothing but tan square 60 degree, divided by 1 plus tan square 60 degree. So this is 1 minus root 3 whole square divided by 1 plus root 3 whole square. Root get cancels with square. So 1 minus 3 is minus 2. 1 plus 3 is 4. So when we cancel this, we'll get the value as minus half. So this is the right hand side and that is the left hand side. So clearly we can conclude LHS is equal to RHS. So by learning the standard rule, signs of trigonometric function and the allied angle property, we can evaluate these problems. Next, find the values of the following. Cot square 60 degree, sin square 45 degree, sin square 30 degree, cos square 90 degree. So here, which means cot 60 degree. Cot 60 degree value is 1 by root 3 whole square, because we have cot 2 times. Next, sin square 45, the value of sin 45 is 1 by root 2. Then since we have square, whole square. Sin 30 is 1 by 2, so whole square. Cos 90 is 0, so 0 square is 0. So here we will get 1 by 3 plus 1 by 2 plus 1 by 4. So taking the LCM here, so 12 is the LCM, so we get 3 4s. Next we have 2 6s, 4 3s. So the value is equal to 13 by 12. Next question. Sin square pi by 6, cos square pi by 3 minus tan square pi by 4 plus cot square pi by 4. So here, whatever the angles we have studied in degrees, we have learnt the conversion of radian measures of the standard angle. So pi by 6 means 30 degree, pi by 3 is 60 degree, pi by 4 is 45 degree. So sin 30 degree is 1 by 2. Since we have square, we'll take it as whole square. Cos pi by 3 is also 1 by 2, which is 1 by 2 whole square. Tan 45 is 1, so 1 square. Next, cot 45 is also 1, so 1 square. So plus 1 minus 1 cancels here. So we have 1 by 4 plus 1 by 4, which is equal to 1 by 2. Next one. Show that 1 minus cot pi by 3 divided by 1 plus cot pi by 3 whole square is equal to 1 minus cot pi by 6 divided by 1 plus cot pi by 6. So let me consider the LHS. So 1 minus cot pi by 3, which is cot 60. Cot 60 is 1 by root 3 whole square divided by here 1 plus 1 by root 3 whole square. So which becomes root 3 minus 1 divided by root 3 plus 1 whole square. So now let us expand these values. We have 3 plus 1 minus 2 root 3 whole divided by 3 plus 1 plus 2 root 3. So which is 4 minus 2 root 3 divided by 4 plus 2 root 3. So taking 2 outside, we will get 2 minus root 3 divided by 2 plus root 3. So let me take this as equation 1. Next we will consider the RHS. So RHS is equal to 1 minus root 3 divided by 1 plus root 3. So now let's take the RHS. So RHS is equal to 1 minus cos root pi by 6, which is root 3 by 2 divided by 1 plus cos pi by 6, which is root 3 by 2. Which becomes 2 minus root 3 divided by 2 whole divided by 2 plus root 3 divided by 2. 2 get cancels. We have 2 minus root 3 divided by 2 plus root 3. So Here we have the cot values and here we have the cos values. So therefore 1 minus cot pi by 3 divided by 1 plus cot pi by 3 whole square is equal to 1 minus cos pi by 6 divided by 1 plus cos pi by 6. So from this we can see equation 1 and 2 have the same values. Therefore the LHS is equal to RHS. Next one. Sine square 60 degree, cos cube 60 degree, secant square 30 degree whole divided by 2 cosecant square 30 degree minus 1 by 2 sine square 60 degree into tan square 30 degree. So we need to find the value here. So sine square 60 is nothing but root 3 by 2 whole square. Cos cube 60 is 1 by 2 whole cube. Secant square 30 degree is 2 by root 3 whole square. Whole divided by 2 into cosecant square 30 degree is 2 whole square minus 1 by 2 into root 3 by 2 whole square into 1 by root 3 whole square. So here root 3 whole square cancels. Then we are left with 1 by 4 into 1 by 8 into 4 in the numerator. Again here root 3 square cancels. So 2 square 4 2s are 8 minus 1 by 2 into 1 by 4. Again here we can cancel a 4. Then here we have 1 by 8 whole divided by 8 minus 1 by 8. So 1 by 8 divided by 8 8s are 64 minus 1, 63 by 8. 8 cancels. The value is equal to 1 by 63. Next one, find x from the following. So here we have one unknown value of x. We need to find out the value of x. X into sine 30 into cos square 45 is equal to cot square 30 into secant 60 tan 45 divided by cosecant square 45 degree into cosecant 30 degree. So let us write the value x into sine 30 1 by 2, cos square 45 1 by root 2 whole square, cot square 30 root 3 whole square, secant 60 degree 2, tan 45 degree 1, cosecant square 45 degree is root 2 whole square, cosecant 30 degree is 2. Next here we can cancel 2 and 2. Then here root 3 whole square is 3, root 2 whole square is 2. Next here we have x into 2 root cancels, 1 by 2 into 1 by 2 is 1 by 4. So here we have 3 by 2. So cross multiply this, 3 into 4 by 2, 2 1s are 2 2s are. So the value of x is equal to 6. Next question. If x into sine 45 tan 60 degree is equal to sine 30 cot 30 divided by 3 cos 60 cosecant 45 degree, then show that x is equal to 1 by 3. So let us write x. Sine 45 is 1 by root 2, tan 60 is root 3, sine 30 is 1 by 2, cot 30 is root 3, 3 into cos 60 is 1 by 2, cosecant 45 degree is root 2. So now on either side we can cancel root 2 on both sides, root 3 on both sides. 1 by 2 cancels. So therefore clearly x is equal to 1 by 3. So thus today in this session we have learned some of the standard values of all the trigonometric ratios and the conversion whenever it is needed. Also we have studied the signs of trigonometric functions in different quadrants. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.